Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. In this session we are going to recognize face and some custom objects with the help of TensorFlow Lite. We are going to create our own custom model for TensorFlow Lite. Okay, so before we move to our practical, friends, if you learn something from our videos, please consider to subscribe our channel. Okay friends, thank you so much, and let's get started. So friends, we are going to detect some custom objects. Also we are going to recognize a face with the help of TensorFlow Lite, our own custom model. Okay, so for that, first you need to install latest opencv version, which is 4.6.0 on Raspberry OS Bullseye 64-bit version. So I have already created the video how to install opencv on Raspberry OS Bullseye. I will mention video link, watch video and install opencv on Raspberry OS Bullseye. Okay, so if I open terminal, I have already installed opencv 4.6.0 on Raspberry OS Bullseye 64-bit version. Okay, so if I run the command here, uname -a, hit enter, and as you can see, this is what 64-bit version. arg64 means it is a 64-bit version. And if I run the command cat space /etc/os-release, and as you can see, Bullseye. So Bullseye and 64-bit version. Okay, so and if I run here one more command, python 3 and then import cv2, hit enter. Now it's import a cv2 module. Okay, then if I run the command cv2 dot version, and if I hit enter, as you can see, 4.6.0. so this is the latest version, okay, which I have installed on Raspberry OS Bullseye 64-bit version. Okay, so now we are going to install TensorFlow Lite on our Bullseye. Okay, so for that I have created here a repository, face recognition TensorFlow. I will mention link of the repository inside the description box. You need to copy paste link inside the browser, then go to the code, then copy from here link. Okay, and we are going to simply clone our repository. So run the command git clone and paste the link and just hit enter. It will clone our repository. Okay, so as you can see, it's cloning. So we have successfully cloned our repository. Now what we want to do, we want to go inside the repository. Okay, so run the command cd space face recognition TensorFlow, hit enter, ls command, and as you can see, this is the bash script for installing TensorFlow Lite on our Raspberry OS Bullseye 64-bit version. So we need to give the first full permission. Okay, so we need to mention here full permission for TensorFlow Lite bash script. Simple. So run the command chmod 775 and mention the bash script name, which is tensorflow-lite.sh, like this way, chmod space 775 and our bash script name, and just hit enter. That's it. So now if I run ls command, as you can see, the color is green. Now it means we have successfully changed the permission. Okay, now we are going to run our script. So simply run the command like this way, / and our script name like this way. Okay, or we can simply run like this way. Okay, I'm going to show you another way, bash and bash, not bsh, bash. Okay, bash space and our script name, script file name, which is tensorflow-lite.sh, and just hit enter. It will install, it will basically not install, it will run our bash script. Okay, as you can see, it's now running. So bash space tensorflow-lite.sh, and then it will run our bash script. Okay, so now it's basically cloning the examples folder, and inside that examples folder we have another script which basically install our TensorFlow Lite on our Bullseye. Okay, so first it's cloning our examples folder. So as you can see, it's cloning. That's it friends. So if I clear the screen and I need to run the command ls, and this is what our examples folder, as you can see. So we are going to open our examples folder from file manager. So let me minimize terminal, and we are going to open our file manager, and here this is what our repository, face recognition TensorFlow. This is what our examples folder. So we need to go inside examples folder. So just click on examples, then we have lite folder, then again we have examples folder, then here we are going to search for object detection folder. So this is what object detection folder, select it, and inside that we have Raspberry Pi folder, so select it. That's it. And this is what the requirements.txt file, this is the file basically includes the requirements for installing TensorFlow Lite. So we need to make some changes. Okay, so right click requirements.txt and open with text editor. Okay, it will open with text editor, and here it is. As you can see, opencv-python, and version is basically old version, which is 4.5.3.56. so we are going to work with 4.6.0. we have installed a 4.6.0 opencv, so we need to mention that version over here first. Okay, so just change this with 4.6.0, or we can say 4.6.0. that's it. So this is how we need to change the version of opencv-python. that's it. Then simply we are going to save the file. Only we need to change opencv version. Okay, then we are going to go inside file and click on save, and that's it. We have successfully saved our file. That is, now we are ready, and we are going to again close all these things, and we are going to open our terminal, and then we are going to run our bash script. So we need to go inside examples folder. Okay, so run the command cd examples. Okay, cd examples, then inside that examples we have lite folder, so mention lite folder. Okay, then again we have example folders. Just press tab button. Okay friends, so cd space examples folder, then lite folder, then examples folder, then we have object detection folder, so obj, press tab button, it will auto complete the folder name object detection. Then we have Raspberry Pi, so ra, press tab button, it will auto complete Raspberry Pi, and just hit enter. Now we are inside the Raspberry Pi folder. So if I run ls command, and as you can see setup.sh, this is the bash script for installing TensorFlow Lite on our bullseye. So now we are ready, and we are going to simply run the command bash space setup.sh. that's it. Just hit enter. Now it will automatically install TensorFlow Lite on our bullseye. Okay, so it's installing. So basically I have already installed the TensorFlow Lite, that's why it says the requirement is already satisfied. Okay, so it will take some time. Meanwhile I will pause video. Okay friends, so friends, as you can see, requirement is already satisfied, because as I mentioned, I have already installed a TensorFlow Lite. Okay, now we are ready, and we are going to simply run the cd command, and we are going to come out from our Raspberry Pi repository. Let's just clear our terminal. Now what we want to do, we want to test our TensorFlow Lite. So we are going to open Tony Python IDE. So minimize all these things, go to the menu, programming, Tony Python IDE, then go to the file, click on open. Then this is what our repository, face recognition TensorFlow, open it, examples folder, then lite folder, then again examples folder, then here we are going to search for object detection folder, then our Raspberry Pi folder, and then we are going to open detect.py. So click on detect.py, click on OK. That's it. So this is what our main script, which basically run our TensorFlow Lite model. Okay, so let's just close untitled. So detect.py, and if I run detect.py, it will start my USB web camera, which I have connected with the Raspberry Pi 4. Okay, and as you can see friends, our TensorFlow Lite is working. It's detected me as a person. Okay, and it thinks that mic is basically tie. Okay, but it's working. As you can see, person. So we have successfully installed our TensorFlow Lite version on our Raspberry OS Bullseye for opencv 4.60, which is the latest version. That's it. Now we are going to create our own custom model for face recognition purpose. Also we are going to detect here Arduino board and Raspberry Pi Pico board. This is our custom object. So we are ready, and let me open again file manager, and we have our repository, which is face recognition TensorFlow. So here, as you can see, we have here images.zip folder. Okay, and right click and click on just extract here. It will extract our folder, as you can see, images folder, and inside that I have shared a Tony Stark images. Okay, so we are going to basically detect here two faces. One is our Iron Man hero, which is a Tony Stark, and another one is myself face. Okay, so we are going to recognize two face. One is Tony Stark and another one is myself. Okay, my own face. And then we are going to detect Arduino Uno board and Raspberry Pi Pico board. Okay, this is what our objects. Okay, so here it is. As you can see, I have already saved some images, okay, of our Tony Stark, and then we are going to create here another objects images, or we can say we are going to save another objects images inside images folder. Okay, so and here as you can see we have here img.py script. So this script is basically capture our images with the help of USB web camera. Okay, so we need to open this img.py. Okay, so we are going to open again Tony Python IDE, then go to the file, click on open, then go to the py and face recognition TensorFlow. This is what repository, and img.py, click on OK. Okay, and this script is basically capture 40 images. Okay, and this is the name of image. So right now this is my own name, Sanket. Okay, so it's capture my own face. Okay, and it's capture 40 images. Simple, and it will save inside /home/py images, and our folder name is basically this one. So we need to mention this path here, copy it, because we have images folder inside our repository. So we need to mention our repository path inside img.py. So just copy the path from here. Okay, and then we are going to open our Tony Python IDE, and here we need to paste the path. Just paste it, delete and Ctrl+V. That's it. /home/py face recognition TensorFlow folder, and inside that folder we have our images folder. That's it. So this is what our path, and this is the name of image, and it will create 40 images. Okay, so now first I'm going to capture my own face. Okay, so if I save the code, if I run the code, so friends, as you can see, we need to simply move our face in front of the camera, then it will create a different angle 40 images. Okay, so if I open face recognition folder, inside that we have images folder. So this is what our Tony Stark images, and as you can see from here it's created Sanket face images. This is my face images. Okay, so 40 images, we have 40 images. Okay, so now we are going to capture our Arduino board image. So now here simply we need to remove this Sanket name with Arduino, and save the code, and I'm going to run the code, and then I'm going to simply move our Arduino board in different angle in front of the camera. Okay, so friends, as you can see, we have now, if I again open the folder which is face recognition, and inside that we have images, and then as you can see we have now our Arduino images also. So image viewer, as you can see, this is what our Arduino board image. So our last image, which is Raspberry Pi Pico board, so here we are going to mention remove Arduino, and we are going to mention rpi Pico, and just save the code, and again same process, we need to move our rpi Pico in front of the camera. Okay, So friends, as you can see, we have successfully captured our last object image. So again, if I open face recognition folder, images, and then we need to search here for rpypico. As you can see, rpypico 40 images. Okay, as you can see, this is what our Raspberry Pi Pico images. So we have done with our data. Now we are going to simply install label emg on our bullseye. Okay, so I am going to just minimize Tony Python IDE. Okay, and then again we are going to open our folder which is face recognition, and inside that we have a text file which basically help us to install label emg on bullseye. So right click text editor, and this is the first command. So copy it from text editor and open terminal, and we are going to simply paste the command inside our terminal and just hit enter. It will install py-qt5-devtools on bullseye. Okay, so I have already installed. Then our second command, which is label emg package. So copy it, our second command, open terminal and just paste it and just hit enter. It will install label emg on our bullseye 64-bit version. So requirement is already satisfied because I have already installed. That's it. So this is how you need to install label emg on bullseye. Okay, so let me close our text file. Now we are ready, and we have now our data. Now simply we are going to draw a rectangle on our object. Okay, so we need to run the label emg software. So just run the command lab and press tab button. It will auto complete our command label emg and just hit enter. Okay, so as you can see, this is what our label emg software. So go to the opendir pi and face recognition tensorflow. This is what our repository, and inside that we have our images folder. So select it, click on choose. Now it will open all our images. Then change save dir, go to the pi face recognition tensorflow, and then select images folder, then click on choose. That's it. We successfully mention our dir for images. Also we mention our save dir for saving our images. Simple. Now what we are going to do here, we need to mention Pascal VOC. Okay, so I have already mentioned Pascal VOC. Simply we need to click like this way. There is three options, the YOLO, then create ML, and then Pascal. Then we are ready now. So simply create rectangle box, and we are going to select our Iron Man hero, Tony Stark face, and simply we are going to mention the name Tony-Stark. That's it, Tony Stark. Click on OK, and then we need to click on save. Then next image, create rectangle box, and then again we are going to select the face, same name Tony Stark. Click on OK, save image. So let me draw the rectangle. Okay, so meanwhile I will pause video. Okay friends, so friends, we have successfully drawn a rectangle on our Tony Stark face. Okay, this is the last image. If I click next image, so here we are going to select our second object, which is our Arduino board. Okay, so again create rectangle box, and we are going to simply draw the rectangle box on our Arduino board, and we are going to simply mention here a name. So Arduino. Okay, this is what our second object, which is our Arduino board. So click on save our next image. Again we are going to select our Arduino board, click on OK, click on save. Second image, create rectangle box, then draw rectangle box and click on OK and save. So now I am going to draw a rectangle box on our Arduino board. Okay, so friends, we have successfully drawn a rectangle box on our Arduino board. This is the last image. If I click next image, and this is what our rpypico. So same way, create rectangle box, and then we are going to draw a rectangle box on Pico. Then here we are going to mention rpypico. This is what our third object. Click on OK, click on save. Next image, create rectangle box, and we are going to draw the rectangle box on our Pico board. Click on OK, click on save image. Next image, create rectangle box, and again we are going to draw rectangle box. Click on OK. So let me draw rectangle box on our Pico board. Okay friends, so friends, we have successfully draw a rectangle box on our rpypico board. If I click next image, so this is what our last object, which is my own face. So we need to draw a rectangle box on my own face for recognizing faces. Okay, so simply create rectangle box and let's just draw a rectangle, and here I need to mention my own name, Sanket. I click on OK, save image, next image, create rectangle box, draw a rectangle, Sanket, click on OK, save, next image. So now I am going to simply draw a rectangle on my face. Okay, so friends, we have successfully draw a rectangle box on our last object, which is my face. Okay, so we have draw a rectangle box on our all 4 objects. Now simply we are going to close our software. Okay, and then we are going to open file manager, then our repository, which is face recognition TensorFlow. Just click on it, and we have our images folder, and inside that we have our image and XML file, image and XML file, image and XML file. Okay, so this is how we need to simply draw a rectangle box on our object. So we have done with images. Now what we want to do, we want to create a new folder inside /home/pi. Okay, so I have clicked here home, and now we are inside /home/pi, and here it is. As you can see, I have created a new folder which is freedom tech. So you need to simply click write new folder and mention the name of folder. So remember one thing, you need to mention same folder name of freedom tech. Okay, like this way, freedom tech, same folder name. Okay, then our Google Colab code will work. Okay, so freedom tech folder which I have created here, then just click on freedom tech folder, and inside that again we need to create a 2 folder. First one is train and another one is validate. So first one is train and another one is basically validate. Okay, then what we want to do, we want to open our images folder from face recognition TensorFlow where we have our data. So images folder, and just Ctrl+A, select all the data, then right click, copy data and go to the home, then our folder which is freedom tech train folder, and just paste our data inside train folder. Okay, then back, then same way validate and paste the data. Okay, so this is how we need to paste our data from our images folder to freedom tech folder to train folder. Okay, then freedom tech folder to validate folder. Okay, that's it. So we have done. Now what we want to do, we are going to simply create this freedom tech folder as a zip folder. So open terminal and let me clear the screen, and we are going to run the command like this way, sudo space zip space -r. Okay, like this way, sudo space zip space -r, then the file name, means then the folder name which we want to create as a zip folder. So freedom tech.zip, freedom tech.zip space our folder name, so freedom tech /star. Okay, sudo space zip -r space freedom tech.zip. Let me show you. I hope I mentioned the command inside text editor. Okay, so I will mention the command, so no worry about the command. Inside the text file you will see the command. Okay, right now there is no command, but I will mention the command for creating zip folder. Okay, so command is like this way, sudo space zip space -r space. This is the name of the file, or we can say this is the name of the zip folder which we want to create. So we are going to create a same name, so freedom tech.zip, and then this is the folder which we want to create as a zip folder. So freedom tech /star. So star for it will basically zip all the content which we have inside our freedom tech folder. That's it. So this is the command. No worry about the command. I will mention the command inside our text file. Simple. So just hit enter. Now as you can see, it's creating zip file, or we can say it's creating zip folder, freedom tech.zip. So we have done. So if I minimize the terminal and go to the home, and as you can see we have freedom tech.zip. Now we need to move this folder on our Google Drive. Okay, then we are going to open our Google Colab. Okay, so now first we want to move our folder on our Google Drive. Okay, so we are going to open our Google Drive. So friends, as you can see, I have opened my Google Drive, my drive. So here right click, click on file upload, and we are going to upload our freedomtech.zip file. Okay, so freedomtech.zip, select it, click on open, and now it's uploading our zip folder on our Google Drive. Okay, so what we are going to do, meanwhile we are going to open our Google Colab. So Google Colab, click on here, and then I am going to just delete all old sessions. So let's just click on a recycle box over here, click on yes, and as you can see, now there is no Google Colab session. So we are going to simply upload our file, our Google Colab file. So click on upload, click on choose file, and we are going to open our Google Colab file from our repository, a face recognition TensorFlow repository which we clone. So just select it, our folder, and this is what our Google Colab file, copy of tfl lite face.ipynb. This is what our Google Colab file. So just click on open. Now it's uploading. Okay, so friends, we have successfully uploaded our file. Also on Google Drive we have successfully uploaded our freedomtech.zip. As you can see, one upload complete. That's it. Now simply we are going to first go here, runtime, change runtime type, select GPU, then click on save. That's it. Then we are going to simply click on connect, and now it's connecting. Okay, so friends, we have successfully connected. Now we are going to run our first code. So let's just run our first code. Simply click on here, and it will install TF Lite model maker and TF Lite support. Okay, so friends, as you can see, we have successfully complete our first code. Here it is, as you can see, a green tick mark. It means we have successfully run our first code. There is no error. Okay, so process is completed. Now just scroll down, and we are going to run our second code. So just click on here. So now it's basically running our second code. Okay, we have done green tick mark. Just scroll down, and now what we are going to do, we are going to mount our Google Drive. Okay, so we need to click here on our third code. It will ask a permission. As you can see, permit this notebook. So simply click on connect to Google Drive. Then we need to select our Gmail ID. Select it. This is the Gmail ID where I have saved my freedomtech.zip file on Google Drive. Okay, so select it, your Google Drive Gmail ID. Simple. Then scroll down, click on allow. Now we successfully give permission to access our Google Drive. Okay, so as you can see, it started process. So friends, successfully mount Google Drive. As you can see, green tick mark, and this is what our folder, freedomtech.zip. Now it will unzip our folder. Okay, so next code for unzipping our freedomtech.zip, as you can see, so just click on code, and it will unzip our all data. As you can see, images. Okay, that's it. Now just scroll down, scroll down, scroll down, and here what we want to do, we want to mention our class names. In simple language, class name means we want to mention our object names. Okay, so I have already mentioned Tony Stark. So remember one thing, friends, here we need to mention the class name same as our label name. So here I have mentioned Tony Stark as a small alphabet, so I need to mention Tony hyphen Stark, Tony Stark. Then Sanket, S also small. Then our other two object, which is Arduino, okay, in single quote, Arduino, and then last one is our RPi Pico. As you can see, let me make like this way. This is how we need to mention our class name: Tony Stark, single quote, comma, Sanket, single quote, comma, Arduino, single quote, then RPi Pico. This is how we need to mention our classes. Then for validate folder, same way. Okay, so just mention like this way: Tony Stark. Okay, then Sanket S is small, then our Arduino board, so in single quote Arduino, then last one is rpi hyphen, not hyphen, basically rpi pico. Same way, okay, Tony Stark, Sanket, Arduino, rpi pico. Okay, so this is how you need to mention your classes names, or we can say your object names over here. Okay, so I have mentioned like this way of 4 objects and their name: Tony Stark, Sanket, Arduino and rpi pico. Then just click on here and that's it. There is no error. It means we have successfully mentioned our class names. Okay, as you can see, there is green tick mark. So just scroll down and then run this code. Green tick mark, success. Then now from here it will create our model. So just click on here. Now it started our process. So friends, as you can see, process is started 1 out of 100, so it will take some time. So meanwhile I will pause video. Okay, so friends, we have complete our training process, as you can see, 100 to 100. Okay, so we have done. Now simply our next step, evaluate the model with the validation data. So just click on here. Okay, then our process completed. Evaluate the model with the validation data process completed, and as you can see, the names of our classes: Tony Stark, Sanket, Arduino and rpi pico. Then now this is the last step, and it will create our model, and our model name is android.tf-lite. This is what our model name. So let's just click on here, and now it will create our model. Okay, so friends, our process is completed. Export as TensorFlow Lite model. Okay, now we have our model ready. Now simply we need to click here. This is the folder sign. As you can see, we need to double click on the folder. Okay, and as you can see, this is what our model, Android TF-lite. So just click on here, click on download. Now it will download our Android.tf-lite model, our own custom model. Okay, as you can see, it's downloading basically. Okay, so friends, we have successfully downloaded our model. As you can see, Android TF-lite. Click here, show in folder, and inside downloads we have our model. Okay, so simply what we want to do, we want to copy and paste this model inside our face recognition TensorFlow examples folder. Okay, so what we are going to do, we are going to simply right click for our model, just click on cut. Okay, then go to the folder. Here it is, as you can see, face recognition TensorFlow folder. Just click it, example folders, Lite folder, again examples. Then here we are going to search for object detection folder. So object detection folder, then our Raspberry Pi folder, and here we want to paste our custom model. As you can see, this is the by default model. As you can see, TF-lite, this is the by default model for object detection with the help of TensorFlow Lite, and here we are going to paste our custom model. So just paste, that's it. Okay, so now we are ready. Now what we are going to do, let me first close our browser, because we have all the done with processes. Now we are ready. Now first what we want to do, we want to mention our model path inside our detect.py. Okay, so simply what we are going to do, we are going to open our Tony Python IDE. So let's just open Tony Python IDE, and here we are going to open our detect.py. So go to the file, click on open, then face recognition TensorFlow. This is what our repository, and inside that we have examples folder again, then Lite folder, then again examples, then object detection, then Raspberry Pi, and then we have detect.py. okay, so click on OK and it will open our detect.py file inside our Thony Python IDE. Okay, so what we are going to do, as I mentioned, we need to mention our custom model. Okay, so let's just scroll down. So as you can see here, friends, line number 115 required is equal to false, and default line number 116 inside Thony Python IDE, line number 116. As you can see, there is basically default model for TensorFlow Lite. So here what we want to do, we want to mention our own custom model. So just hit enter and then mention the same variable default, okay, is equal to, in single quote, here we are going to mention our own custom model, which is android.tflite. okay, so android.tflite, that's it, android.tflite. okay, so then what we want to do, we want to mention here like this way, bracket, and this default model we are going to make comment, just we need to mention hash. okay, so this is how we need to mention our own custom model. okay, so now if you don't want to use a custom model, you want to go with a default model, so again just mention hash for our custom model and just uncomment hash from by default model. That's it. Now you can use a by default model, but right now we want to use our own custom model, so mention hash tag for by default model and just uncomment hashtag from custom model. okay, so default is equal to android.tflite and then a bracket like this way. okay, so this is how we need to mention our own custom model inside detect.py. the line number is basically 116, and after that we mention our own custom model. okay, so simply save, and now we are ready. Now I am going to start the code and it will detect my face, and then we can see my name on my face, means my name on my rectangle box. okay, so simply if I start the code, and as you can see, friends, it's detected my face, there is a rectangle on my face and there is a name. But what we are going to do, we are going to change basically a text format. okay, so go to the file and go to the open, then same folder. okay, so Pi, face recognition, TensorFlow, examples, Lite, examples, object detection, Raspberry Pi, and inside that where we have detect.py, inside that we have utils.py. so just click on utils.py and click on OK. it will open utils.py and just scroll down, and here it is. We can see font size, font thickness, and the text for color. So color is basically right now red, so we are going to change the color 255, and this one also 255, and last one we are going to mention 0. it will change a text color. okay, and then what we are going to do, we are going to change, let's say, font thickness, we are going to mention 2. okay, and then the rectangle, I don't want a red, so I want to change the rectangle. So just scroll down, and here it is. As you can see, cv2.rectangle method and the text color. So by default it will take this color for rectangle, so we are going to mention our own color. We are going to mention green color, so just remove the text color variable, and here we are going to mention our color, our green color. So 0 255 0. That's it. This is how we need to mention a color, our own color, means green color. okay, so save it, and now if I run detect.py, now as you can see, we can see the name Sanket, so it's detected my face. okay, perfectly. So now what I am going to do, I am going to show our Arduino board, okay, to camera. okay, so I have here my board, Arduino board, and as you can see, it's detected Arduino board. okay, as you can see, it's detected Arduino board. Same time it's detected my face. We have Arduino board. Okay, then we have RPi Pico here. And as you can see, now it's detected RPi Pico also. And as you can see, it's detected RPi Pico. Okay, the RPi Pico. Now we are going to show our Tony Stark face. Okay, so Tony Stark image. Okay, and as you can see, now it's detected my face and Tony Stark face also. Okay, there is a rectangle on our Tony Stark face. Okay, so friends, we have successfully detected our 4 custom objects with the help of TensorFlow Lite on Raspberry OS Bullseye 64-bit version. It's work really fast. Right now it's a little bit slow because same time I am detecting the object and same time I am recording, okay, with our Raspberry Pi 4 Raspberry OS Bullseye. That's why it's little bit slow, but otherwise it's work really fast. Okay, so I hope you learned something from this video. We'll meet our next video. Till then, thank you, take care, and bye bye.